Alright, so in today's video I wanted to talk about complex fractions. We just reviewed these today in my pre-calc class, and I showed two distinct ways of doing them. One of them is to get a common denominator and reciprocate and multiply. So that would be our first step. So common denominator. This could be 4x over x, we multiply by x over x, over plus 8 over x. And that's going to be all over in the denominator. I'm going to change that 1 to a 2 over 2. And then we have x over 2. So now I have a common denominator in both the numerator and the denominator. So going to go ahead and add those. So 4x plus 8 all over x. And then I'm going to reciprocate and multiply. I'll reciprocate on the fly here. This would have been 2x, 2 plus x all over 2. So my 2 will be in the numerator, and I will have 2x in the denominator. I'm sorry, 2 plus x in the denominator. Maybe I should not have reciprocated on the fly. So when we do that, when you reciprocate, let's say I notice 4x plus 8, that would factor. That would, well, now to 4 times x plus 2 all over my x times 2 over 2 plus x. So by doing that, we go ahead and can cancel out common terms. So when I multiply numerator times numerator, I end up with 8, and denominator times denominator, that's just x times 1, becomes 8 over x. So that's one way of doing this. Get a common denominator, reciprocate, and multiply. So I'll show you how to do it using a second method, but go ahead, like this before we go on, and I will show you in 2 seconds. All right, second method here. Another way to deal with this is just to figure out in the whole fraction, all of the denominators, what is the lowest common denominator. So here I have an x in the denominator, and here I have a 2 in the denominator. So I'm going to multiply the top and bottom by 2 times x, because 2 and x are both in the denominators. So distribute that up top here. 2x times 4 is 8x. So that's this multiplication. Then multiply here. This is 2x times 8, which is 16x over x. So those x's will cancel out and will just leave us with a 16. Then going to the denominator, 2x times 1, well, that's just 2x. And 2x times x over 2, those 2's cancel, and that leaves us with just plain old, x squared. All right, so you're almost there. So in the numerator, I have a common factor of 8, so I'm going to factor that out. 8 would be times, that's a wiggly parenthesis, plus 2. And in the denominator, there is an x in each term. So let's factor that x out, or undistribute it, if you want to think of it that way. So x times 2 is 2x, and x times x, that was the x squared. So these two things are going to cancel again, leaving us with just 8 over x. So you'll notice with this second technique using the LCM, you're going to get there in a little bit fewer steps. So for that reason, a lot of people prefer method number 2 to the first method. All right, so I'll use that second method again. Let me know in the comments down below if you like the first or the second method. Mathematicians kind of lazy by nature, so they prefer to do something that takes fewer steps if possible. So I'm going to multiply Let's see, I have x, 2x, 3x, and 4x. I'm going to list those out. X, 2x, 3x, and 4x. So, the least common multiple of 2 and 3 and 4, that's 12. And the least common multiple of x, that's just x. So I'm going to end up multiplying the top and bottom of this complex fraction by 12x over 12x. And I'm seeing that I just went off the screen there. So 12x over 12x. So that fits. All right, so go ahead and distribute 12x times 2 over x. Well, the x's are going to cancel out, and it's just 2 times 12, or 24. Then I have a minus sign. 12 times 1, 12x times 1 is 12x, and the 2 and the x are going to cancel out. So 2 goes into 12 6 times. So that takes care of our numerator. Now we'll look at the denominator. I'm going to distribute this 12x on the denominator. So 3x goes into 12x 4 times, and 4 times 4, that would give us a 16. Then multiply 12x times 1 over 4x. 4x goes into 12x, the x's will cancel, and 4 goes into 12 3 times. So our final answer here is what, 18 over 13. So that's what can happen. Let me put this up here where it's more visible. 18 over 13. So sometimes we don't have, there's no x left over. There's no x going to be in the final expression. So sometimes that'll happen. Don't get alarmed by that. But this was kind of nice how that worked out. So there were 3 little examples, not hard ones, but to give you an idea of how to go about solving those complex equations, or simplifying those complex fractions rather. So hopefully you got some value out of this. If so, wouldn't mind giving me a thumbs up, or maybe even subscribe down below. Also, let me know in the comments which one of those methods are you going to try out the next time. Until the next time, this is Noldy signing out.